Alright, it seems we are live, and this is something that I wanted to fix on this project for a long time. And the issue is that I have all of the components in the schematic in a nice library that has all of the manufacturer numbers bound to the components. I've double-checked the pinouts, so everything is fine there. But my footprint library is still a mess. So I have some of the components in my custom footprint library, and others are spread out around the KiCad default libraries, and that's not how I want to have it. So I wanted for a long time to kind of move all the footprints to my own library so that I can do the work, double check all the components, and then know that they work. So I don't want anything to change with any updates. And also another big benefit of having the footprints in the custom library as well, and this approach is something that I've been following throughout this project, and it's been very, very useful. And having them in a custom library is also good because I can then easily modify footprints that are on this PCB. For example, the footprint for this transistor is heavily modified to make sure that all of the vias are created as part of the footprint, so that I don't have to every single transistor on the PCB. So a lot of the duplicate work is eliminated, adding the vias as pads in the footprint. And on the PCB, this ends up being exactly the same thing as placing a via, because it is modified such that it doesn't appear on the mask layer. So it becomes covered. So what I needed to do basically was to copy all the footprints into my own library, and I found that there was a functionality in KiCad that which is called archive footprints. So using this functionality, I was able to then create my own library that contains all of the footprints that are part of this board, and I've placed them at swedishembedded.pretty. Which is located in the same directory as my project. So let me just bring up the terminal here. But what still remains to do is to remap all of the components to use the new footprints instead of being bound to the footprints that are in the KiCad libraries. And to do that, all I have to do is modify my custom library of the schematic components to make sure that all of the footprints point to my custom library. And this is what this video is going to be about. I don't know how well this will work. I think it will work 100%. But as with any live video that I stream here on YouTube, there is no way of knowing. And I can only guess. I can only do some research, and then I just get to work and I live stream it. So if you haven't subscribed already, subscribe to my channel and you'll get notified whenever I stream live. So let's get started. I have all of my footprints in the directory called swedishembedded.pretty. And now I have to open up my my library. Let's see. Lib. That'll be the lib. And I'm going to be doing this through the text editor because doing this manually is going to take a very long time. But luckily KiCad has a text format which is easily modifiable using a text editor. So all we have to do is remap every line that sets the value of F2. I think we should be fine just replacing all of the F2 fields. There could be some components maybe that, for example, don't have a footprint. We can check, for example, the G and D component. Okay, that's yeah. Maybe I can search for like def G and D, which would be one of the ground footprints that provide this ground frame around, for example, my analog circuitry. But I think we should be fine just replacing F2. And I'm going to be double checking this using Git. So I have all of the files in Git, which makes it easy for me to see the difference after I'm done with this. And then we can just double check that all of the correct lines have been replaced and nothing else. So to do this, I'll write a regex in Vim to match, I guess, F2. Let's match the start of the line and then F2 and the quotation mark and then anything. Let's see. I always forget whether the default mode is greedy or not in Vim. So I guess we can just do like this and then match the group which comes after that of anything that's not a quotation mark, I guess, and it would be like 0 or more characters. So this should match what I'm trying to match, and I'm going to be replacing this with F2 and then the first match, which is in the parentheses. Or actually, yeah, of course, this will start with the library name and the colon. And then this should actually create the correct replacement, I think. Let's try this. So yeah, this seems to have worked just fine. I'm going to save this file and I'm going to do git k on the actually let's do all. Actually, we don't need to do all because we only have the master branch here. But I'm going to check the uncommitted changes, and I can check the library to make sure that the only things that have been replaced are the things that I intend to replace. So let's see, we have all of the footprints that have been in the default libraries are now in our custom library, which is looking good. However, I think I shouldn't have the underscore there actually, but I'll fix that later. Let's see. First, I'm gonna check that everything is correct here. So custom is also getting replaced. Anything that's been previously in the custom library is now in this generated library. Let's see. It all seems fine, I think. Let's see. Diets, package, everything seems fine. Module. Oh, right, yeah. My library contains a bit more components here than what I've used on this schematic. Let's see. Custom QFN. So my dog and I here at Swedish Embedded have had a discussion about selling this design, and my dog was basically concerned about her supply of bones. So she said, like, as long as you can guarantee my supply of bones, I'm totally for it. So I've been looking at ways to make this available. And by purchasing this design, you support my live streams on YouTube. And you also get all of the videos, all of the detailed documentation that I've live streamed so far about this design. You get all of that for free. Plus, you get the full design, and you can use it in whatever way you want. You can reuse it in a commercial product. You can use parts of it. You get this library. You get the custom footprints that I've created, and you get some more components as well. So I have some components here that I haven't used on this design, but I really don't see any reason to remove them. You can get them as well as part of the package. Let's see. So inductors and LEDs, custom inductors. The problem, however, is that any of the any of the footprints that haven't been used in this project, they will actually not work after this replacement. So that is a bit unfortunate. Let's see. Of course, resistors will work just fine because this is using the generic R0402 package, which is also used on this PCB, so that will work just fine. But some of the custom footprints may not work. But that doesn't matter for this project, so that's just something that will need to be fixed after the fact. Let's see, resistors, RF shielding. And besides, anything that doesn't work, I can just look at this video or look at this history, this change history, and I can see where it was located before I made the replacement. And then I can move it to my custom library instead. And that is how I think I will be working from now on. I've liked this idea very much, to have everything in a custom library. It simplifies so many things. And I have every component identified by a key. So if it's a chip, it's called IC, and then it has the name of the chip. And that maps very nicely to the BOM. And to me, that seems like the perfect way, the ultimate way of working with libraries in KiCad. I made a video before on which I called the ultimate way of doing this in Ultimate Designer, and it was exactly the same strategy. And I still believe that this is the right strategy to use to avoid doing any work twice, and just to instantiate the components on the schematic, and then whenever an update needs to be done, you just update the component in the library, and then you update all of the instances of that component on your schematic. Let's see. So this has been. This looks good. I will just close this, and I've removed some of the branding on this PCB just to make it more generic before I save all of this to the archive. And let's see here. So this seems to be pretty good. Right. So one thing I'm going to do now is actually I'm going to replace this underscore. And then I'm going to test all of this. So I'm going to start with updating all of the field values. This should update all of the footprints as well. So this will go like this. And now is the moment of truth. So when I do this update to this PCB, I wonder if things will get or if things will continue to be exactly the same, or if something is going to change here. So let's see. Update PCB from schematic. Let's see if this works. Let's see. So I wonder if it has updated the references of the footprints, or if there is anything else I need to do. So update, let's see, so what I could do here is actually update all of the footprints from library. All footprints on the board. And I can actually check if the changes have taken effect by opening this PCB file in the text editor and actually checking that the fields have been updated, or the references for the footprints have been updated. So it's still working. It is taking a while. And now everything is going to be completely messed up on the schematic, on the PCB if things don't go as planned. But I think it should be fine. Maybe it didn't even update the... Oh yeah. No, or no. It didn't update the references. Okay. I guess I'll have to do the same thing for the PCB file. But first, I'm going to check if it has been updated here. Which of course hasn't been, because I have to reload the file. I have to close the schematic and I have to open it again, and then I will have all the changes. Let's see. So, is this gonna work? No? Why didn't I get all the changes from my library? That's very strange. Maybe I edited the wrong library. Maybe I had a copy of the library that I edited. I have to combine all of my copies into one library. So I have everything. Let's see, so let me just move this window here. And this one seems to have the updated footprint. So did I forget to select some box in the dialog here? This is supposed to replace footprint. But it doesn't, because this is the way KiCad works. It has so many artifacts from the old way of doing things. The way where you have your modifications on the schematic, which is a way I don't agree with. Let's see. Okay. Maybe I did something else stupid. At least now it seems to be updated. And let's call update PCB from schematic. Let's see if we get the new footprints. Alright, at least we're getting somewhere. So we have a few things that seem to be missing. Because I have to add this to my list of libraries. FB lib table. I wonder if it reloads the FBlib table when I do this update. Actually, I'm going to do this first. Did PCB from schematic. apparently not. So maybe if I do like this. I'll save it this time, just in case I had any changes there. Okay, so let's see, let's start this again. Maybe it will work this time. Nope. So it seems to me that based on these messages, there is no prefix. I don't know if it expects to have a prefix or if it just looks for the footprint in all of the libraries, but I'm going to check that. So let's see. I'm going to just search for 402. So this has not been updated. Regarding the 3D models, I am not going to be updating them just yet. So I only care about the footprints themselves. And I have no idea why it doesn't update them, but I'm just going to be doing it this way. So instead of replacing the F2 line, I'm going to be replacing module space. Let's see if this works better. So presumably if I had created this board using the footprints from my library from the beginning, I wouldn't have to be doing any manual changes to this after the fact. But to me it would seem that KiCad should have been updating the footprint from the fields on the schematic. Let's see here. So let's see if we get any errors now. Maybe, oh, cool. So apparently now it's okay, right. So it worked, but it has changed several fab layer labels to defaults, because when it was exporting the footprint, presumably it has exported the label as the name of the footprint, which is also an artifact of the way that KiCad traditionally promotes that you should be creating the schematics. I don't think there is a standard way to do it, it's just the more widely accepted way of doing it. So on the fab layer, what you get is the name of the footprint, because traditionally the footprints had very short names, like maybe resistor 402. I think that's a bit odd to have the full name of the footprint on the fab layer. I think it would be good to have some custom description, maybe have a description of where a connector is intended to connect or something like that. But yeah, I guess that's just a matter of taste. So now I have presumably updated. I'm just going to update the footprints actually. I think this should work for the future as well. So at least I could now update the PCB from Schematic once I have changed the footprint references directly in the PCB file. But I'll just run the update of the footprints so that I can make sure that the footprints come from my custom library and not from anywhere else, which is almost guaranteed to work. This is just the last test. This is all of the footprints that are now in this custom library. So the workflow from here on would be to copy the footprints from the KiCad standard libraries into this custom library before actually using them. And that's kind of like the philosophy I used for the schematic symbols, where I see the KiCad default footprints as templates for my own footprints that I actually then use on my PCB. So things like, for example, adding bias through the ground pad for some chips, these things are going to be very simple to achieve using this custom library, without having to worry about file permissions or things being overwritten if something is updated. And the library is then saved as part of the project, so that any changes are always tracked in the same repository, and one can always be sure that every single component and every single footprint is at exactly the same has exactly the same structure as it had when the circuit was designed. And this footprint has caused me some trouble because it has commas in it. I have to remove the commas, because when KiCad exports this as part of the BOM file doesn't actually enclose this into quotes. So the commas are then interpreted as field separators, which causes this line or any line that has this footprint to appear wrong in the BOM. And this didn't actually work as intended just yet. Let's see. Footprint not found. Why is footprint not found? Really? So for some reason, it isn't finding my... Let's see. So... FP. Oh, yeah. Actually, this should work. This should work. So, what could be the problem here? Footprint not found. I thought that using the local fblib table should have worked, but apparently it doesn't. So we're going to do this through the dialog. PRJ mod is the project directory. And now we should be able to update the footprints. So what is the reason to have fblib table in the directory? KiGad has been changing a lot of things in the way that they handle libraries. So there is a lot of concurrent ways of doing things, which hopefully will converge to something more standardized. Haha, Martin the perfectionist. Yeah, I think a good like my goal is always, and this is just something that personally just makes me happy. And the goal is to, if I do my best every day, then I also have the chance to do it better tomorrow, and that's kind of encouraging for me personally. Like if I make sure that I have done my best, at least I don't have to think about like if some problem arises, I don't have to think, oh, how stupid that was that I didn't do it properly from the beginning, and now I have to deal with this problem that has occurred because I didn't pay due diligence to actually reviewing the schematic properly, checking all the footprints, checking all of the component numbers, and then having to deal with those problems later. I prefer to avoid that because it's so easy to do something really stupid like ordering a part that has a SOT23R package instead of SOT23, and the regulator that has SOT23R package is wired differently. So if you solder it to a place where you're supposed to have a regulator that has a SOT23 package, it's going to be shorted to ground. So I really like to avoid such problems, and I think this requires a bit of perfectionism, I guess, because even though I still feel like there's always something that I always ask myself, is there something I forgot? Is there something really stupid I did on this board that is going to make this board completely broken? We'll see. Do you have a problem shipping from GLC PCB? Okay. I placed an order with them, and I placed an order actually with a stencil. So that's going to be interesting. I'm going to be testing a stencil for the first time. to solder all of the components at once. So up to now I've been soldering components one by one, but I'm very excited about trying out the stencil way, because I think that can save a lot of time. And I got this offer now from PCBWay. They've been very helpful, very thorough in their replies, and I think the initial cost it would be a very high cost of to order the 20 boards that I need, without actually knowing that everything actually works. Because we don't know that yet. The board has just been designed, and it's impossible to know if everything is going to work as expected on the final product. So I decided that I will try them for this. I will order 6 boards from them, all populated, and then the other boards I will populate on the PCBs that I now ordered from GLC PCB, using the stencil that they will provide, which is going to be interesting. And I think I can get some prototypes running much faster using this approach than if I have to wait until the boards are manufactured by PCBWay. And it's not because PCBWay seems to be slow. It's because PCBWay has to source all of the components, and that has lead time. But I'll do that as part of a different video. That's irrelevant for this video. I'm just reading through all of the comments that are flooding the comment stream. Barcode to PC scanner. What would be the use of that, actually? Why do I need a barcode scanner? I don't use any barcodes. Yeah, microwave simulation software on Linux. I think the best package that I've used there was this, what's it called now again? QSIM, or no, it's called Quark. Quark, yeah, I think it's called Quark. It was pretty nice, but it had its own problems, and it's not developed anymore, so I kind of abandoned it. Alright, so all of the footprints seem to be updated now, which is nice. Okay. No, it was called QUCS. Or? Yeah, it's called QUCS. Universal Circuit Simulator. It had some nice features for simulating things like waveguides and similar circuits. But they have some version that is like their proprietary version that is being updated more than the open version. But the open version is still probably worth checking out. So WIPLD. Yeah, this looks nice. So this actually does the structural simulation, so it can simulate solid antennas and how the waves interact with the surrounding objects as well, right? Like the casing, for example. Yeah, seems to be pretty professional. I'll definitely check it out. Thanks for the tip, Damien. I had the impression that QUCS was abandoned because I think my impression was based on the fact that I've checked out. I don't know if there was some repository somewhere or something, but it wasn't. I checked some repository that wasn't updated for a very long time, and then I seen references to some newer package that they were developing, into which they were putting all of their work. So that gave me the impression that the original QUCS has been abandoned in favor of something newer. But I don't know all of the details about that, so maybe it isn't completely abandoned. Right. QUCS Studio, exactly. Zolver. Oh, it's a 0. I see. I don't really have that much of experience with microwave stuff. I think it would be fun to get to dive deeper into it. It's definitely a huge huge area of electrical engineering. So does this allow importing a Gerber file, for example, and checking the soundness of the onboard antenna, for example? How do I unsubscribe from from earth porn on Reddit? I don't think I even subscribe to that. They just send me updates on that, like, oh, it's trending on earth porn. I want to opt out. I'm gonna check that later. Let's see. Okay. This one seems pretty advanced. Nice. Lots of very good tips, Damien. Much appreciated. XNEC 2C. Is there any date somewhere as to when this was last updated? You're posting tips faster than I can check them out. I've heard of Engine. I haven't used it though, but this seems to be well known. Right. All very nice tools. I've seen this description of a guy that built a radar. It was pretty detailed description with all of the schematics as well, which was one of the projects that got me more interested in RF stuff. And actually, I always have it in the back of my head to kind of dive into it deeper. Let's see, it was an FMC radar. It's Henrik Forsten that made this. He designed this PCB himself, and he printed it at Wash Park and soldered it using a stencil, by the way. So he has some tutorials posted on his blog, and he was able to achieve pretty cool stuff with this radar. So normally the raw signal kind of gets only picture like this, but then he actually implemented the technique for identifying individual objects as the radar moves in a straight line. So that I don't remember what it's called though. It's a mathematical algorithm that actually creates a picture and not just shows the different targets in the view of the radar. But this looks like a very interesting project to check out for anyone watching this video. It has more PCB design and more information about specifically about how this type of radar works. He built a synthetic aperture radar, where this synthetic aperture is actually just a calculation that is done on the returning signal, which can produce things like this, for example. So all the images combined can pretty much produce the image of this view, kind of like what they use in sonars that can produce detailed image of the C button. where the sonar scans the bottom with continuously with waves that return to the sonar, and then combines the images to produce this more real image that can be overlaid over a map, for example. Anyway, I am done with this video, and that's it for now. See you later.